So, good evening, everybody. The Archaeological Society Malta and the Department of Classics and Archaeology are delighted to welcome you to this, our third in the series of talks for 2020-2021. I know that there are participants from France, Germany, and the UK and Greece. A special welcome to them. I'm Patricia Camilleri, I'm president of the Archaeological Society Malta, and I'll be mediating this evening's session. I'd like to ask you to make sure that you mute yourselves so that we don't have any echo issues or noises off, as sometimes happens on these video links. Video is, of course, totally optional, but please note that we do have the speaker's permission to record this lecture this evening. All lectures in this season will be a collaboration between the Department of Classics and Archaeology, University of Malta, and the Archaeological Society Malta. Thanks go to the head of department, Dr. John C. Betts, and to Professor Nicholas Bella, ASM Vice President, and the person who is our link really between the society and the department. Just a word about how we'll proceed for this evening. I'll be introducing our guest speaker, Dr. Petros Chatzimpaloglou, then turning the virtual floor over to him. Please do ask your questions using the chat, which you can access at the bottom of your screens, or some of you may find it at the top. You can ask your questions anytime during the talk, and I shall ask Petros to answer at least some of those queries at the end as time allows. This evening's lecture is entitled Provenance Investigation of Stone Tools and the Position of Malta in the Neolithic Network of the Central Mediterranean Sea. So let's move on. A quick word about our guest speaker. Dr. Petros Chatzimpaloglou is a postdoc researcher at the Department of Archaeology at the University of Cambridge. He holds a BSc in geology and has spent the last 6 years building up a strong archaeological background through his MSc and PhD studies. His specialism is the scientific sourcing of stone tools and artifacts and the archaeological implications of that knowledge. His doctoral research was based at the McBurney Laboratory in the Department of Archaeology at the University of Cambridge and was part of the ERC-funded FRAGSUS project, Fragility and Sustainability in Restricted Island Environments. It explored the possibilities of accurately sourcing prehistoric tools and artifacts made from chert. The investigation was conducted on archaeological material found in several Neolithic sites in Malta, including Giganti and Skorba. He gained his PhD early this year and is currently involved in 2 interdisciplinary research projects focusing on prehistoric communities of the Balkans. So, without further ado, I pass the floor on to Petros.
Hello, everyone. Thank you very much for coming. Actually attending. 2020 does not approve mobility in general. So I would like on my behalf to thank Patricia, Nick and Anne for organizing this event. And also I would like to thank Archaeological Society Malta and the University of Malta for organizing generally this series that allow us to promote our work in a broader audience. So let me start with the presentation. So my presentation for today lecture will be on provenance investigation on stone tools and how this could provide indication on what was the position of Malta in the Neolithic network of Central Mediterranean Sea. This will have 5 parts. This will have 5 parts: introduction, information about my methodology, the Neolithic context of Malta, results and discussion of my findings, and the conclusion. It will be good to put some guidelines on the terms. So I have to say that provenance investigation or sourcing stone tools and artifacts is an interdisciplinary research that falls within two fields, lithic analysis and geoarchaeology. Lithic analysis is the investigation of any raw material that have been modified, used, or discarded from humans in the past. While geoarchaeology, an easy explanation could be, it's the field that uses techniques and methods from the earth science in order to address complicated issues or questions that cannot be answered with the traditional archaeological approaches. So this type of study allows us to find the source location of raw materials, which could help to draw possible routes between the location of the raw material and the site of interest, and eventually allow us to create a network within which people were moving along and possibly interacting with other group of people, societies, or communities. This is particularly important in regions such as the Central Mediterranean Sea, as you can see in this map, where estimating or understanding which routes people back then were followed is not something easy to detect or straightforward. And particularly considering that we don't have any writing information provide us idea what was happening back then. So this is an alternative route that could help us answer these complicated questions. Regarding the material we're going to talk in my presentation, it will be chert, which is a raw material commonly used during prehistory for tool crafting. And it had abundant geological sources in the broader region. In comparison with other materials, such as obsidian, it is always difficult to distinguish between sources, between chert sources. And it's always necessary to have a robust scientific investigation on these raw materials to detect these differences. And it's exactly this approach that is key and allow us to connect chert finds from archaeological sites with their actual sources. The methodology I employ through my research is something I created through my PhD investigation, and it starts first from selecting chert archaeological finds and raw materials to compare. It is important at this stage to always have raw materials, I mean sources, to compare the findings of the findings of the chert artifacts and tools. Because doing a scientific investigation on the artifacts, just on the artifacts, it wouldn't have any meaningful archaeological importance, because the answer the archaeology normally looking is not straightforward. But when you're having a raw material to compare, even if eventually the source you have chosen is not compatible with your artifacts, it's one step forward, because you have excluded a source, a possible location that you may think that people were going there. So you can address your focus of your investigation elsewhere. The next step is to employ geological techniques to investigate the petrological characteristics of the archaeological finds and the raw materials. And for this presentation, I will use the macroscopic analysis, FTIR, and LAICPMS. From these techniques, we collect results such as the macroscopic characteristics of our samples, their mineralogy, and the elementary composition. From the interpretation of those, we get first an understanding of the different qualities of the raw materials, the type of sediments that end up to be solid rock today, the environment this process have been conducted, but also the whole process from the initial sediment to the final solid rock. In the field of geology, this is called diagenesis. The comparative study of this information will allow us to identify the differences between these sources, and this will help us with great certainty to connect shared tools and artifacts with their sources. And the principle of that is based that is highly unlikely for different sources through this method to provide the exactly same information. So when an artifact is connected with a particular source, it will be almost impossible to be also compatible with another. Before going straight to the methodology and the results, I would now say some information about the Neolithic context of Malta. And for those of you that they don't know, Malta is a group of islands that lies in the middle of the Mediterranean Sea, as you can see on the map on your right. And during the late Neolithic, large-scale monuments known as stone temples were built. Example of which you can see. The first picture is from M. Niger Temple, which is located on the south of Malta. And the second one is Gigantia, which is found in Gozo, and probably it's the most famous Neolithic temple of the islands. The last decades, there have been plenty of projects investigate the Neolithic of the Maltese islands. The last one, if I'm not mistaken, was Fragius project, and it was under the umbrella of this project that I did my PhD research. This project investigated several sites, Neolithic sites, on Malta, on the Maltese islands, as you can see in this map. 4 have been located in Gozo and 2 on Malta. Namely, this is Santa Verna, Sarah Circle, Tacharla, Cordin, Gigantia, and Scorba. In these slides, you see the period, the sites and the year they have been excavated, plus some information about these sites. Sarah Circle was the only site that have not been excavated during Fragius, but have been excavated from a predecessor's project of that. But the findings, and especially the bone collection, have been thoroughly investigated from some colleagues of mine, during Fragius, and the findings have been, although we're still waiting, I could say exciting. Overall, the project have focused on 3 settlements, 2 temple sites, and 1 burial site. When we put all of these sites in an archaeological timeline, we see, although they were not active throughout the period of late Neolithic, the findings of them could provide us a holistic understanding of what is happening to the late Neolithic, and could contribute to a better understanding of who were the Neolithic Maltese people. My work aimed to identify the sources of the chert assemblances found within these Neolithic sites, and I employ a robust interdisciplinary methodology on samples from the sample semblances and chert sources from Malta and Sicily. Now we'll dive in a bit to more results, so have some patience in the next slides. Starting from the fieldwork and Malta, I conducted 3 field sessions where I investigated and sampled certain outcrops and certain assemblances from the island. As you can see on the map on the right, Maltese geology is relatively simple. It has only 5 rock formations, and within only one, certain outcrops have been recorded. And from my research, I found 2 main locations of these outcrops, one in Malta, one in Gozo, which is, you can be seen exactly the location with the green triangles, and both of these locations were found on the west of the islands. Starting from Malta, as you can see in this picture, I investigated a region close to Bahria village, and the highlight shapes show the places I examined, and while the yellow circles show where the certain outcrops are found, and they are close to 4 Erich Bay. Example of the material I recorded in this area, you can see in this following picture starting from the top left and ending down to the bottom right. I did also field investigation on Gozo in the area which is close to Fungus Rock. Again, the highlighted areas show the places I have investigated for these resources, and the certain outcrops have been recorded within the pink square we can see on the map, which is actually an internal valley in this landscape just behind the Fungus Rock and the karstic formations that can be found in the edge of the island. And the outcrops were sampled along the road that is pointed out with a black arrow. These are some pictures of the material I found there. In terms of quality, they don't differ much from the Maltese one, but it's certainly a more restricted outcrops than the ones in Malta. The next stop was to visit Sicily, and there I focused my interest on the most important said sources of the island. Here we have a geological map of the island divided by age, and as you can see, the island, except of the much greater size in comparison with Malta, it has greater diversity and it's more geologically complicated. And to try to be more effective in this field work, I restricted their areas of interest in 2 main locations. The first one was Southeast Sicily, which have been selected for 2 main reasons. First of all, there is strong archaeological evidence of important prehistoric activity in the region. And the second is that the majority, it presents certain sources of the majority of the formations found in the whole of the island. And the dark red circles point out the sample locations of my fieldwork. An example of the material I found, you can see in the following pictures. We're starting from Monte Tabuto, which have archaeological significance also, because it's considered a place that we have prehistoric mining in this region. However, the material I found there was not so promising, which either be because it have been depleted, or for other reasons that I have not yet defined, maybe they weren't actually mining chert material or flint over there. But anyway, there are other cases, such as Monte Rosso Almo, where we have huge exposures of limestone, within which we found extensive outcrops of multiple chert. Example of which you can see in these pictures, where you can see the different size, shape, and colors that have been found in this area. Finally, the other two locations are recorded in this region. One was, as you see in the picture on the left, it was on the bedrocks, on the riverbed of Valona River, where I found a massive sequence of red bedded chert. It was a height, I think, more than 50 meters, which is really impressive and promising for such kind of research. And on the right, there is a typical black translucent chert material, which which someone could say that it's considered flint, a term that archaeologists constantly use to describe generally this material. The next stop was in West Sicily. This area is not supported from archaeologists for various reasons, but I got the opportunity as I visit Sicily to go there, mainly because there I could find chert sources that they are not recorded in Southeast Sicily. So it's a great opportunity to have the broader spectrum as possible on the different resources found on Sicily. Example of which you can see in this following picture. On the top right, you see a black chert, which is similar to which you can find on the southeast of Sicily. But on the bottom left, you can see a type of orange chert that I have been located in this region that I haven't found an equivalent in Southeast Sicily. So at least for that, my trip to West Sicily had to provide something new. From all the above, what I want you to remember is concentrated in this table. And the things I want you to hold for later is that Malta, the Maltese chert, could either have brown or gray color, in comparison with Sicily, that can present colors from the whole spectrum. Another factor is that Maltese chert consistently present white spots on their surface, which for the purpose of the research, we call it spotted. While this feature is not reported in the same consistency on the Sicilian material. Moving now to the lab work, this is going to be the hardest part for most of you, but eventually you understand what I want to say. We start from the mineralogy of our samples. Here are two diagrams representative for the Maltese and the Sicilian material. We see that the Maltese chert have high concentrations of opal A, which is considered the softest silicon mineral that could be found on a rock. When I mean the softest, I mean in comparison with others, could be easily broken. And this has an effect of how easy eventually a rock could break. In comparison, the Sicilians there are dominated by quartz, which is the hardest silicon mineral. An additional difference is that the Maltese has important amounts of calcite, something that's not reported to the Sicilian one. Until now, with the first two techniques, we have recorded some indications of the differences between the two locations and the sources they both present. However, there are many times in the past that these results are not sufficient to detect their differences, or occasionally, especially the microscopy, have been misleading. It lies always the addition of the geochemistry and the important models we could get from them that allow us to have a holistic approach of understanding of each source we need to examine and eventually compare with the shared artifacts. So starting with the major elements and using the first model, which considers the concentration of iron, aluminum, and manganium, we see that the the Sicilian chert have different type of sediments in terms of major elements, and they are widespread along the left line of the triangle, while the Maltese ones are gathered in the region considered of biogenic origin, but most importantly, they are all gathered in the same exactly region. Similar the situation on our next model, which again we use the concentration of iron and aluminum, but now we use also the concentration of titanium. Here we see that again, the Sicilian cherts are more widespread. So we see that in Sicily, basically, you have different type of sources, different type of material. But again, the Maltese one is guarding a specific area, region, which could be addressed as a mixed environment between pelagic and continental margin type of environment. The final step of this process ends up to rare earth elements. Why is important? Because they initially, they deposited in the very beginning of the formation of the rock. And their concentration does not change as long as the time passes and is not affected from major geological and tectonic events as happens with the major elements. So this could be an additional key of the special character of the rock we're examining. Any local influence can be seen on the fluctuation of the concentration between each element. Regardless of that theory, and just looking at the diagrams here, which shows the patterns of each source, we see again and confirming that the Sicilian one is not just one source, there are multiple, as they spread throughout the diagram. And we can see in West Sicily, for example, we're starting from concentrations around 0.001 and reaching in 0.1 concentrations. The fluctuation varies extremely. In comparison though, the Maltese one has, all the samples has similar pattern, more smooth, and they all are gathered in a region which could be suggested around 0.1. The hard part has finished, so you can got a small brief of what you have seen. But all of this is important because all of this hard work that need to be done on the sources will help us enormously when we're judging, when we're examining the shared artifacts. It's the main overload because, as you can remember, on the archaeological material, we have restrictions in the period of how long we can examine them and what type of examination we can do on the artifacts. So we gather as much information from the rock, so we can limit also the examination on our artifacts and also the possible effects that any technique could have. And note here that all the techniques I have chosen for my PhD and I presented here have none to minimum effect on the artifacts. And this is one more importance of this type of methodology I use. But now let's continue a bit to the archaeological research, to the church assemblances, which have found important church collections in all of these sites. And I would like to remind you that sites we examined was the four in Gozo, which is Sarah Circle, Gigantia, Santa Verna, and Tacharla, and the two in Malta, which was Corba and Cordil. Most of the artifacts were macroscopically related with local chert formations. example of which you can see in these following pictures. To make the connection, I would like to remind you that these ones have either brown or gray color, similarly with the ones we found on the field of Malta, plus they represent this spotted feature, the white irregular shapes on the artifacts, similar as our rock resources. However, many artifacts on these assemblages are not related with local chert and have been identified as exotic material, which means it has been imported from somewhere else. Example of this material you can see in these following pictures. The theory suggests a Sicilian origin of this exotic material based on the proximity of Malta with Sicily, the named chert outcrops, and the Neolithic activity of Sicily. However, it wasn't been tested until now and was part of my research to test this theory. I saw this diagram not to get any information from that, but to point out again the significance of using a source to compare with your artifacts. Because if we didn't have a source, after the macroscopic evaluation, we reach in this stage. And although we see differences between the patterns, without the source, we could not claim with solid evidence if these artifacts we investigated are local or not, or where they are coming from. And it's one thing to do a theoretical discussion or of the origin of the artifacts, another thing to have spent an enormous amount of time and money to do a scientific investigation and still be on a theoretical level. So this scientific evaluation, what it does is use the microscopy and mineralogy as a guide to make an initial connection between artifacts and chert rocks, and then have geochemical models to test the link between rock and artifact. And for this presentation, I will show you 3 examples. The first case is these artifacts on the top left with the local material found on Malta, and the table on the top right shows the main common characteristics. Again, is the color, the spotted feature, and now we also include that they both are made from opal A, as I said before, the softest silica mineral. Go to the geochemistry now, and use the same exact model as before. Now we see that the archaeological samples from all the assemblages fall exactly on the same region as the Maltese material. Similarly, is the results on the second model, where once again, the majority of the samples from all the assemblages fall exactly in the same region as the Maltese material. And our final model we used before, with the patterns, we see exactly the same event, that they're almost identical pattern and the concentration of the high level. One point here, the samples of the artifacts are less than the before, just for illustration reasons, not for anything else. So we have the scientific evidence to confirm the original theory that the Neolithic people, for starters, were using the local material. We have indications so far, now we have solid proofs. The next example is the sequence from Valona River in Sicily with the red artifacts you see on your left. Again, they present macroscopic and mineralogical similarities, and you can see on the table on the top right. The results, however, in the geochemistry suggest something different than before. We see that all our artifacts are gathered in the biogenic sediments region. They are close together, which suggest a common origin, However, they are not related with the Sicilian material we have co-examined. Similar is the situation of our next model, that basically suggests they are made in different environments. And with our final model, basically confirms that these artifacts, although they may have a common origin, they for sure not related with the Sicilian material we initially thought they might be related. And considering our fieldwork in Sicily, that we haven't found any similar outcrop that could match these artifacts, we should look somewhere else from where these artifacts may be coming from. The final example is these two black artifacts found on Malta with the multiple black sources found in Sicily. Again, on the bottom left, I have a table which presents the common characteristics from the two previous techniques. In our first model, we have some interesting findings. We see that the two artifacts have, to some extent, some relation with each other, which possibly could have a common origin, and that some, but not all, of the resources from Sicily are related with them. We don't have a perfect match as Malta, as the example with Malta, but we have strong indications. This further confirmed in our next model. Well, again, we see the same sources to be close to the artifacts we're examining. We're excluding the sources from West Sicily and Monte Utica, and we have strong indications that the sources from Monte Rosso Almo and Modica are closely related with these artifacts. An important thing is Monte Rosso Almo and Modica present black chert that they're coming on the same, they were found within the same limestone formation. So although they may have a geographical distance, in terms of geology, these formations are very close together. And this is also confirmed with our final model, with the rare earth pattern. Strongly suggests that these artifacts are related with sources from Southeast Sicily, and potentially either will be from Monte Rosso or Modica. If we maybe some will say that the compatibility that's shown in Malta, in the local material, is not the same here, but have in mind that we have much more samples from the Maltese material than we have from the Sicilian, and also we only had 2 artifacts to compare. But for the restricted amount of analysis, this is almost a great match. So as a conclusion, and recapping what we said, through my methodology, I found strong indications that the Maltese people, the Neolithic Maltese society was using local material for their tools and artifacts. Furthermore, with great certainty, they were imported material from Sicily, and actually the most probable location is from Southeast Sicily, either Monte Rosso or Modica. But moreover, we have clearly found that Sicily was not the only location that these people were importing material from, and further research will be due. And going to the bigger picture of the Central Mediterranean, we have the means and we confirm the connection of Sicily with Malta, but also we have the tools now to establish how far these people were going or from how far material was reaching Malta. Some research have proven that obsidian from Pantelleria and Lipari was coming to Malta. They could be possible locations. However, there is no church source reported on these islands. So our focus would go somewhere else. The next candidate could be Sardinia, also a great exporter of obsidian. The good thing about this location is that they also have church sources. So with the same technique, we could further check if Sardinia is the location of the undefined church, the location from where raw material are coming from these undefined church artifacts. But further, we could go and look at Italy or even Tunisia. Italy could be more suitable, not just that it's considered closer, but also it has other raw materials that have been suggested to be imported to Malta. Tunisia, it's a more difficult situation, basically because we don't have a lot of information in terms of archaeology and geology of what's happening there. So at this stage, it wouldn't be a possible scenario, but regardless, we have the methodology to test any theory. We just need a source to compare. And even if this fails, we can go even further. We can take Greece, which the west part has a great amount of church resources along the coastline. And why not even another country, the south? This presentation provides a methodology that even if it manages for the first attempt to completely solve what was the position of Malta, it certainly confirmed the connection of Sicily, but also suggests that it was involved in a network that was greater than it was previously assumed. And now we have the toolkit to test any possible theory or any possible scenario. The good thing is that the Maltese people were not just making great stone temples. Using the material that they're using, even when they were resting and enjoying the landscape of Malta, were actually provide us small piece of information on a small piece of rock. And now we have the decoding system, or as the methodology, to decode what they were saying and where they were going or where they were coming from. Before the end, I would like to thank Cambridge University, Fractus Project, and Heritage of Malta for allowing me to conduct this research. And finally, I would like to thank all of you that you attended and remain until the end to this presentation. Thank you very much.
Well, thank you very, very much indeed for that talk. You've walked us through a very interesting geological journey. There are a couple of questions, if that's all right with you, Petros.
Yeah.
The first one was from Professor Kassar. She asked it early on, you partly answered it, I think, but is there a database which includes chert or flint composition from the wider Mediterranean? And if so, did you compare it as when? Which
Can you repeat again, because I missed some parts?
Sorry, she was suggesting, she was asking, is there a database from which includes chert and or flint composition from the wider Mediterranean? And if so, did you compare to it as well? So you partly answered that, but is there a database? Can you get that information?
I assume when it suggests composition, it means geochemical and elementary composition. As a database, I would say no, because geochemistry is only applied the last couple of decades inconsistently, and always, because in terms of geology, chert is not so important as other formations. The data are not as consistent as they should be. It's highly likely because of sourcing and archaeology that eventually at some point will have a huge database. But another important aspect of this is the techniques we use, because depending the techniques of, except until recently, when have been more standardized process, the results we get in terms of composition were diverse. Either would be limited to specific elements or to a specific group. So I suppose one is meaning a database in a comprehensive analysis for all the elements that are possibly presenting in a rock. So, but in general, no, there is not. And even if it is, it would be highly likely to be used because the techniques differ and they will be difficult to compare. Maybe in the future, though.
Okay. Another question from Dr. Bella Gregory in the UK. How many pieces of chert in Malta have you looked at, referring to micro rather than macro analysis? How many pieces? Are there a lot?
I suggest, when I expect, you mean samples?
Yes, perhaps if she doesn't, Isabel perhaps can answer.
Hi, sorry, samples. Yes, I was just trying to get a sense of the assemblage that you analyzed in the laboratory. I'm just curious. Thanks.
The artifacts or the rocks? Sorry, one more clarification.
How many bits of chert tools in total from Emnidra, and what? Like, I'm trying to get a sense of the size of your assembly.
I didn't analyze any samples from Emnidra. The assemblage I had access was Tacharla, Santa Verna, Cordin Scorba, Sarah Circle, and Gigantia. And in total, it was 120. And for elementary, I might analyze only 90. I hope that answers the question.
Sure.
Oh, yes, thank you very much. Thank you.
Thank you for the question, Isabel. Eleanor Sherry is asking, is there any particular pattern regarding which raw materials were used for different tool types? For example, were exotic raw materials used for prestige items versus local for more everyday generic tools like scrapers?
Okay. I will just say from experience, I spent some time on that matter, but I didn't do my main focus on sources. So I could say that everyday material and not important material were made from local. Scrapers was only on particular exotic material, and there was attempts to have scrapers from local material, but I presume wasn't as effective as the exotic material, the brown one. And there was generally a tendency that the exotic, like the red ones and the black chert, to be used either as a tool to modify the local one or as blades.
Okay, I think that answers that. This is from Anton Bouget, I think. Is there a pattern of usage of local or foreign material according to phase? And what is the ratio of local to foreign material?
According to phase,
phase?
No, I cannot answer that. It's a step too far. But what I can say, if this helps, there is the different ratios in terms of the sites. For example, Scorba, which I don't think is a coincidence, is closer to the exposures in Malta. It's the close because it's very close to Form Irk Bay, has high amount of local material in the assemblances, and all the sites in Gozo, they have less local material, and interestingly, they have a brown exotic material to meet the ratios that we found in Scorba. I cannot answer on the phase question exactly, but in terms of the different sites, you can see some difference in the ratios.
Oh, that's interesting. Is there a possibility that there are any untested sources of chert in Sicily which might match the Maltese samples, or are you pretty certain you've got that covered?
You can never be certain as long as you have walked literally the whole island. I believe I have covered most of the east part of the island. West Sicily, though, it needs a more thorough investigation because it's a more rough terrain, but also nobody can estimate what will be the outcrops found. Even if we are talking about the same formation, it could easily be a different type of outcrop on the west side of the island. Mm-hmm. So it is possible there are some resources that haven't been tested, but they will be in the west of Sicily for sure.
Mm-hmm. Just a follow-up question from Elena. What was being used as percussors? What you did mention that before.
Sorry, I don't understand.
What was being used to actually create the tool? Was there a difference between the tool being made and the percussor, the thing that hit it? Sorry, I'm being very basic here. The chert used to actually create the tool.
If I know what was the percussion material.
Yes, yes, what they actually used.
My first answer will be high quality chert, possible for certainly imported from elsewhere. Which exactly I'm not sure, but I don't think they would need to use any other element than chert. And because I say that because for what I have experienced through examining the artifacts, it seems that they are actually using exotic chert to create other tools and artifacts. And I get this impression basically because I think, I'm not sure, but I think some of the artifacts and the tools we found there, they arrived already as a tool on Malta. Mm. Mainly, I base this argument mainly because they're specific chert. We don't found any debitas or debris of that material. I only find broken tools.
Interesting. This is a question from me. Which of the cherts that you looked at is the hardest? You may have answered this and I missed it. Is there a difference between the strength of one chert against another, depending on its color, for example?
Oh no, you cannot answer this question based on the color. That's a totally false route you're falling there. Your answer, basically, it's in terms of quality, what we say. your answer could be based mostly on the mineralogy. So what I said that the Maltese one is mainly made from opal A, which is the softest material, a silicon mineral, which breaks more easy than the ones made from quartz. So we could see on the bottom of the ladder is the local material. The rest, especially the Sicilians, you need further investigation because all of them are made from quartz, which is the strongest one. This group of not local ones, to decide which is stronger or not, you have to test again on mineralogy and see which ones have additional minerals, which are not related with silicon at all, and this will have effect on their strength. But I haven't tested that. And to be honest, most of the colorful, the most translucent one, I consider them stronger. Another factor, when you see a shirt that is translucent or have high values on translucency on them, it means that it's purer in a sense that it's 99%, if this, I just say as a term to understand, 99% made of quartz. When you see shirts that they are not so translucent, this means they have a mixture, so additional minerals, low quality and low concentration on silicon.
Yes, Eleanor is helping me out with my description of a percussor, hammerstones. She says that that's the correct word to use.
They have found, if I'm not mistaken, a lot of greenstone materials in Malta. Don't think there were in the sites I examined. It is possible greenstone was used, but I don't have any evidence on that.
Felicity from UK is asking, is there any evidence of other materials being used to form the tools, to be used as like hammer tools, or like, I don't know, bone or horn or anything like that? Or are we talking always to form these tools at that time? They always used.
I haven't did so much research on this matter, but all of them are a possibility, because these people seem to be skillful when they're creating the artifacts, and each material you suggested has a different use. So when you want to ask to employ pressure to do this other type of flaking, you may not need to use a strong rock. Maybe you need a bone, or you need to put, like, how you call it, a type of cloth, if the term is correct, maybe I'm mistaken, to minimize the effect, to miss this pressure flaking, to make this in the edges, to make it sharper or make it less sharp. But all of these are possible depending what they wanted to achieve, and I'm sure they could easily use it.
Sure. Another follow-up from Professor Kassar. Which elements are you attributing color to? E.g., for example, red equals Fe, ferrous, gray equals what, and black equals what? What are the elements that are making them attributed to color?
It's not such a straightforward answer, because Fe, which is iron, depending the chemical state it is, could be red, but also could be yellow. And gray and black I'm not considered, because there's multiple variation you need to consider before addressing into a specific element. But red is for sure is related with iron. The others, it varies. You need the chemical composition for that, or you can actually go to simple chemistry and see what they are suggesting. But always, when you're talking about specific samples or specific findings, you need to evaluate them with an analysis to be certain.
Okay. I'm very interested in the color, because obviously those examples you showed from Sicily are absolutely beautiful to look at. Of course, you looking at them from the scientific point of view. But is there a geological reason why the colors should be different in different areas? Is it random?
No, it's definitely all random, not random at all. It's what they say, it's the whole process from sediments to solid rock. The most simple answer on that is that the colors to each rock, regardless if it's cert or not, is given by impurities. Maybe one percentage of iron can color a whole rock that is like 20 meters high. It's based on impurities and basically the mixture of impurities. Maybe if you have iron and maybe a bit of magnesium, Mn, it's symbolized, it could be dark red. But also if the iron is in other states, could be dark yellow. But this is because the quartz don't actually give the color. It's the other small trace elements that give the color. And it have been addressed specific elements with specific color, yes, but it always lies on the concentration and of course the environment that these rocks have been produced. They have make this mixture of elements, a cocktail, if you more like it, that gives the final color. And also you must be aware the original colors that you find beneath the surface slightly alter when they go on the surface, because the environmental conditions can actually change. And I give it coming again to the example of iron because it's the most easy. Occasionally something that considered red below the surface, because they're coming up and the environmental conditions are completely different, they alter their states and they make it yellowish or even green at some point.
Fantastic.
So for example, the big sequence that I showed you in Valona River, which it's a bedded red chert, in the very, very bottom, they become dark red and then they become green.
Well, perhaps we can bring this talk to a close. I'm fascinated by it because here you've got this lovely marrying of science to archaeology and to the greater knowledge about trade, contacts. I mean, this is giving that information a real scientific base. And I think that's a wonderful contribution. And I'm sure everyone was very interested to hear what you had to say this evening, which was really, really interesting. So thank you very much for all of you. And you were had about 60 people all on the online today. We look forward to seeing everybody again next time, and that will be on Wednesday, the 20th of January, 2021, and our speaker will be Dr. Tamar Hodos, Reader in Mediterranean Archaeology at the University of Bristol, and his talk will be Extraordinary Objects, Ostrich Eggs as Luxury Items in the Ancient Mediterranean. If anybody wants to join the Archaeological Society Malta, please go on the website and you'll find the information there, and you'll be supporting us with our peer-reviewed journal, which is starting online soon, and also with the advocacy work and in support of all things archaeological in Malta. So sincere thanks from the Archaeological Society Malta and the Department of Classics and Archaeology University to Dr. Petros Chatzimpaloglou this evening for his stimulating talk tonight. And we look forward to seeing you again on the 20th of January. And a Happy New Year to you all. Thank you so much. And thank you, Petros.
Thank you very much for the invitation. It was a great opportunity. It was with a great pleasure I give this presentation. Thank you for the questions too. I will be open for more questions if you like. And if someone is interested, I could give some publication for my PhD. And I hope I see you all again, and Merry Christmas to everyone, and take care.
Yes, hope to see you in Malta, not just online.
I can't wait.
This has been recorded and will be found in a week, something like that, on our website if anybody wants to listen to it again or pass the link on to a friend. Thank you so much, everybody.